Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे आमे फ्रेस्नेल डिफ्रैक्शन रो फ्रेस्नेल्स एजम्पशंस विषय रे पढिबा ऑलरेडी आमे फ्राउनहोफर आउ फ्रेस्नेल डिफ्रैक्शन भितरे डिफरेंशिएशन पढ़ी सारिछु ओके सो फर्स्ट आमे यदि इंट्रोडक्शन टा देखिबा फ्रांसिस्को मारिया ग्रिमेल्डी ये जने साइंटिस्ट जे कि इन द ईयर 1663 रे ही मेड the first observations on the diffraction, but however unfortunately he died without giving any explanation for this diffraction phenomenon. Okay, so he observed that light into a dark chamber while entering through a very narrow obstacle in a rectilinear path of light, then diffraction occurs. Okay, so he observed that the shadow of the obstacle was much bigger than its geometrical projection. Okay, and this confirmed that there is a deviation माने बंके जाउची तार रेक्टिलिनियर पाथ रु लाइट टा ओके डेविएशन फ्रॉम द रेक्टिलिनियर पाथ ऑफ द लाइट रेज which can neither be interpreted as reflection nor as refraction. Okay, so Grimaldi also observed that the shadow is not very sharp. Okay, पूरा sharp है कि shadow टा रहुनी, rather it contains bright and dark fringes. Okay, এটা fringes no printing mistake अछि fringes. Thus the phenomenon of bending of light around the corners of an obstacle and enroachment of light into the regions of geometrical shadow is known as nothing but your diffraction. Okay, এটা ଗୋଟେ ନୂଆ phenomenon जोटा कि से आविष्कार करले. Later on scientist Robert Hooke and the great scientist Isaac Newton wanted to explain the observations of Grimaldi using their corpuscular theory of light, but they could not. Okay, corpuscular theory द्वारा भी यार explanation करिबा संभवपर हेई पारला नहीं. Okay, so later on scientist Augustin Jean Fresnel in the year 1818 was successful in explaining this diffraction phenomenon using Christian Huygens wave theory of light. Okay, Huygens wave theory विषय already तमे पढ़िଛ. Okay, जो थरे कि मेन जदि पॉइंट्स देखिबा ताले सेथिरे से सेकेंडरी वेवलेट्स कथा कहिसंती. Okay, so each point of the primary wave will be regarded as the sources of secondary wavelets. Okay, so Fresnel जो ए diffraction को explain कले ता पई से किछटा assumptions नेले. Okay, so let us now see what are the assumptions made by Fresnel in order to explain the phenomenon of diffraction. So number 1, a wavefront can be split up into a large number of strips. Okay, এই স্ট্রিপ को आमे कहिबा कोन ना फ्रेनेल स्ट्रिप्स बा फ्रेनेल जोन्स बोली की कहिबा. And these strips or zones are having very small area, and the area is so small such that each point on the wavefront will act as a fresh source of secondary waves in all directions. Okay, so Huygens wave theory asila. Tapare second point ko aso, the secondary waves emanate from each element of the wavefront continuously. Okay, continuously eta baharibo. Then third point re, the resultant amplitude at any point will be obtained by the superposition of all the secondary waves reaching from various Fresnel strips or Fresnel zones. Okay, then fourth point, the effect at any point due to particular गोटे जदि आम फ्रेनेल जोन रो देखा तार इफेक्टा जेकोसी पॉइंट रे इट डिपेंड्स ऑन द फॉलोइंग थ्री फैक्टर्स. नंबर वन, the distance of the point from the zone. Number two, the inclination of the point with the reference point to the concerned zone. Okay, माने जो एंगल टा क्रिएट करिवो. तापरे नंबर थ्री रे the area of the zone. Okay, so let us now move further. Consider now this figure. Okay, so here you can see this is a figure where light is coming from this source S. Okay, and it is allowed to fall on a narrow slit. Okay, we have taken here a narrow slit AB, and we are getting the diffraction effects, and this is observed on a screen, right? Screen gote ame neyechu QOR. Okay, now you can see here the central point is obviously O, which is the central bright fringe. Okay, and there is spreading of light in the geometrical shadow region. Okay, so spreading is occurring at an angle here. This angle is theta. Okay, so this angle can be made from the point Q here to the point P, okay, which is at the center of this slit, right? Now actually what happens is, as per Fresnel's assumptions, the effect along any direction will be proportional to 1 plus cos theta. Okay, जे कौनसी डायरेक्शन रे फ्रेनेल्स एजम्पशन हिसाब रे आमे देखिबा ताले तार इफेक्टटा प्रोपोर्शनल रहिबो with the factor 1 plus cos theta. Okay, which is known as obliquity factor. Okay, यहाँ को हमें कहिबा obliquity factor. Now suppose हमें ए डायरेक्शन फास्ट देखिबा नॉर्मल डायरेक्शन PO, ताले एथिपई एबे थीटा रो वैल्यू केते हबो 0 डिग्री हबो, and hence the effect will be maximum because 1 plus cos theta, so cos theta mane cos 0 hegala, so 1 plus 1 equal to 2, it will be having the maximum value, right? So it will have the central bright fringe here at the point O, right? And the resultant effect along the direction here PA, जदि आमे P रू A आड़ को जिबा ताले थीटा रो वैल्यू एबे केते हेगला टोटल 90 डिग्री हेगला, राइट? ताले एबे जदि आमे टोटल इफेक्ट देखिबा along PA, this will be proportional to 1 plus cos 90, which is 1 plus 0, so यार वैल्यू टा आसिला proportional to 1. Okay, so PO रे आमे देखुतिला it was proportional to 2, having the maximum value. So along PA this will be half the value along PO, right? So a important point here to remember that according to Fresnel, the diffraction is caused by the interference of the innumerable secondary wavelets. माने असंख्य secondary wavelets बाहरिबो तांको भितरे interference हेबो. Okay, एई जो secondary wavelets कोटु बारुची, these are originating from the various points of an unexposed portion of the same wavefront. Okay, so same wavefront माने एटा होची प्राइमरी wavefront, एथिरु सबु पॉइंट रू secondary wavelets originate करूची ता माने. Okay, अच्छा, let us now see another path which is PS. Okay, here PS माने P रू एबे उल्टा डायरेक्शन रे along the source एबे देखिबा ताले एबे थीटा रो वैल्यू केते हेगला 180 डिग्री, right? And the resultant effect will be now 0. काहे कि 0 हैला because cos 180 डिग्री रो वैल्यू आमे जानि छु एटा -1, so that obliquity factor हेगला 1 plus -1, that is equal to 0. That means we conclude here that the amplitude of the secondary waves along the backward direction is 0, or in other words, no ray of light can travel in the backward direction. So in this way, Fresnel was able to explain the diffraction by considering the secondary waves which are originating from various points of the same wavefront. Okay, so Fresnel observed that the rectilinear propagation
of light is only approximate. ओके रेक्टिलिनियर जो माने सीधा गोटे लाइन रे लाइट प्रोपागेट करूची एटा गोटे एप्रोक्सीमेट एजम्पशन and the secondary waves undergo constructive as well as destructive interference even in the geometrical shadow region alternatively. Okay, and thereby they will give you the diffraction phenomenon. Okay, so at the end another point here to remember, all kinds of waves exhibit the phenomenon of diffraction. মনে রাখো সে ওয়েভটা লঙ্গিচুডাল হো কিংবা ট্রান্সভার্স হো, all these types of waves exhibit the phenomenon of diffraction. Okay.
Thank you.